Okay, welcome back to our class for this subject for our final week module number 7. So our topic will be about resonance. So first, we will know what is resonance. So resonance is a condition wherein the total current is in phase with the total voltage. The circuit power is unity. So take note sa atong resonance, ang atong power factor is unity. So here we have our series AC circuit at resonance. So we have here our circuit. So natay given. So since series man, we have R, XL, and XC. So to resonate the circuit, we have voltage EL is equal to EC or XL is equal to XC. So FR, so what is FR is the resonant frequency. Ang iyahang unit is Hertz. So FR is equal to 1 over 2 pi square root of LC. Where ang atong LC is the inductance, ang unit is Henry or H, and C is the capacitance in farad or F. So in series AC circuit, the impedance of the circuit is minimum and is equal to the resistance of the circuit. The current in the circuit is maximum as it is limited by the resistance of the circuit alone. And since the current is maximum, the power of the circuit will also be maximum. So please take note for that. Since at series resonance, the current flowing is maximum. The voltage across L and C are also maximum. So for our next topic, we have Q factor of a series resonant circuit. So sa ato ang series resonance, the PD across L and C builds up to a value many times greater than the applied voltage. This voltage magnification produced by resonance is termed as Q factor of the series resonant circuit. So ang voltage di ay na magnify, na na-produce atong circuit, kay gitawag siya nga Q factor. So there is also a formula for our Q factor. So Q factor is equal to voltage across L. So itong L is the inductance or C, which is the capacitance, divided by sa ato ang applied voltage or the total voltage. So to simplify, we have Q factor is equal to EL divided by ET or XL divided by R, or is equal to, so ang XL diba we all know sa atong last topic that 2 pi FRL divided by R. So take note for our important formula. The Q factor of a series resonant can also express in terms of L and C, the inductance and the capacitance. So pwede pud ta mo gamit if given manggali ang ato ang L and C. So Q factor is equal to 1 over R multiply with the square root of L over C. So take note also for this formula. So take note that the Q factor of a series circuit indicates how many times the PD or the voltage across L and C is greater than the applied voltage. So dapat ang voltage sa ato ang inductance and capacitance is mas dako pa sa ato ang applied voltage. Example, a series RLC circuit is connected across a 110 volts. If the Q factor of the circuit is 20, then the voltage across L and C at resonance will be 20 multiplied sa ang 110. So our Q factor our voltage across is 2,220 volts. So dapat mas dako ang atong voltage across L and C kesa sa ang applied voltage. So after sa atong Q factor, we have a bandwidth of a series resonance circuit. So kani siya, it is a range of frequencies over which the operation of electrical device is satisfactory. It lies between 2 points on either side of the resonant frequency where current fails to 70.7% of its maximum value at resonance. So sa itong series resonance circuit na atay maximum value which is the 70.7%. So there is our formula. So remember nga BW is the bandwidth, F1 is the resonant frequency. FR, our F1 is the lower cut of frequency. Our F2 is higher cut of frequency. And our I is the current at resonance. So, kani sila na siya formula. So, for the formula for solving bandwidth, F2 minus F1 or FR over Q. So, solving for our higher cut, we have FR plus 1/2 of our bandwidth. And for the lower cut, we have FR minus 1/2 sa atoang bandwidth. So take note for our 3 formula in bandwidth of a series resonance circuit. So let's have an example for bandwidth. So we have here a series RLC circuit has R 100 ohms, L 100 new hertz, and C is equal to 100 PF is connected across a 10 volt variable frequency source. Determine the natay unknown nga resonant frequency, current at resonance condition, C voltage across L or C at resonance, D is the Q factor of the circuit, and E is the bandwidth, and F is lower and higher cutoff frequency. So daghan tag isolve. So first, we need to solve for A, resonant frequency. So solving for resonant frequency, iba na tayo formula nga 1 over 2 pi square root of LC. Since given ang atong L o C, so pwede na to masolve ang atoang resonant frequency. So we have here 1 over 2 pi square root of L. So ang L is 100 times 10 negative 6. So take note tayo. Dapat na to i-close o open parentheses. Multiplies ato ang C, capacitance nga 100 P. Ano sabi ng P? So, P is negative 12. So, our resonant frequency will be So, dapat i-check na to if na-close ba. Okay. So, sa gawas. So, always check ang atong positive, ay ato ang close ang atong parentheses para di ma-syntax error. So, our resonant frequency will be 1591549 or 1,591,549 Hertz. So Since taas kaayo, pwede nito siya i-convert. So, pwede siya. So, pwede na ito. 1,591 kilohertz or pwede po, para mas short, we have 1.59 megahertz. So, ang mega, diba, is times 10 raised to the power of 6. So, we have here our resonant frequency. So, next, we have current at resonance condition. So, solving for current, since given ang atoang voltage, which is 10 volts, so, divide sa itong R nga 100 na given sab. So, our current will be 0.1 ampere. So, for C, voltage across L or C at resonance. So, solving for our voltage across. So, XL is equal to 2 pi FRL. So, na-solve na nato itong resonant frequency. So, we have 2 pi 1.591 raised to the power of 6 megahertz. 2 multiply sa itong L nga 100 times 6 hertz. So, our XL will be 2 pi negative 6. So, our XL will be 999.65 or approximately to 1,000 ohms. But atong ipangayo is voltage across. Diba nga, EL is also equal to AC. Since na natay XL, so our voltage across 0.1 multiplies ato ang 1,000. So our voltage across L or C will be 100 volts. So, manata sa C. Next, we have our D. So, D is Q factor of the circuit. So, formula, Q is equal to XL over R. So, daghan tag formula sa ato ang Q factor basta given lang ang ato ang mga value. So, sa mas dalita, 1,000 divided by R, which is 100. So, our Q factor will be 10. Then, pwede po mo gamit ani 1 over R multiply to square root of LC or Q is also EL over E. So, same paghihapon ang ilahang answer. And for our E, so, we need to solve for our bandwidth. So, formula for bandwidth is FR over Q. Since solve na tanan, we have 1.591 to the power of 6 divided by ato ang Q, which is 10. So, our bandwidth will be 159.1 kilohertz. So, this is our bandwidth. And for our last unknown is the lower and higher cutoff frequency. So, formula base. So, we have FR nga 1.591 plus 1/2 plus atong bandwidth nga 0.1591. So, our lower cut is 1.67 megahertz. And for our first lower, we have 1.51 megahertz. And our higher, so positive, negative, rather change. So, 1.67 megahertz. So, this will be our final answer. answer. So, very long, no? So, dapat kabulota sa formula sa tuang resonance. So, next we have, so kung naay series, we have also a parallel AC circuit at resonance. So, we have here our circuit. We have E, our R, L, and C. So, parallel na sila. To resonate the circuit, BL is equal to BC. Where atong FR formula, we have 1 over 2 pi multiplied to the square root of 1 over LC minus R squared over L squared. So, FR is the resonant frequency in Hertz, R is in ohms, L inductance in Henry, and C capacitance in Farad. If the coil resistance is small as in general, so our FR formula will be 1 over 2 pi square root of 1 over LC. So the total impedance of the circuit at resonance is, so for the formula for the total impedance, Z is equal to 1 over CR. So a pure resistance. So in parallel, the impedance is also called a dynamic impedance. At parallel resonance, the impedance is maximum since L over C is very large. Thus, with the impedance maximum, the current is minimum. So, sa series na to, diba, if maximum ang current, maximum po ang impedance. But here, in parallel, if ang atong impedance is maximum, ang current is minimum. So, kabaliktaran niya. So, general circuit of a parallel resonance. So, take note na no capacitor is perfect and can be considered to consist of an ideal capacitor in series with a resistor. So, formula sa atong general circuit, if parallel atong resonance, we have 1 over 2 pi square root of LC multiply RL squared over RC squared minus L over C divided by minus L over C. So, R12. So, formula for our resonant frequency. So, take note. And for our last topic, for our Q factor of a parallel resonance circuit. So, at parallel resonance, the circulating current between the two branches is many times greater than the line current. This current amplification produced by the resonance is termed Q factor of the parallel resonance circuit. So, naapod ta sa o Q factor sa atong parallel. So, formula for Q factor, current on L or C divided by IT or the total current. Or pwede po IC over IT or E over XC divided by E divided by L over CR. So, daghan tag formula. So, take note lang mo, ani. So, Q factor, XL over R, 2 pi FRL divided by R. Same sa series circuit if kaniang atuang given sa atuang problem. If the coil resistance is small, so if gamay daw ang coil resistance, so pwede ta gamit 1 over 2 pi square root of 1 over LC. Then Q factor will be 1 over R square root of L over C. Take note that the bandwidth formula for parallel resonance circuit is the same as the series resonance circuit. So, same ra sila o formula if sa atuang bandwidth. So, let's have an example for parallel resonance. So, a coil of resistance 10 ohms and inductance of 0.2 Hz is connected in parallel with a 2.5 microfarad capacitor. Determine the first is the resonant frequency, B, Q factor of the circuit at resonance, and C is the dynamic impedance. So first, we need to solve for resonant frequency. So formula is Fr is equal to 1 over 2 pi multiply with the square root of 1 over LC minus R squared over L squared. Since given tanan, so substitute ra nato. So 1 over 2 pi multiply ang square root of 1 over LC nato is L is 0.2 Henry. And our C capacitance is 2.5 raised to negative 6 since micro minus R 10 squared over L squared, which is 0.2 squared. So our resonant frequency will be 224.93 or approximately to 225 Hz. And next is our Q factor. So formula 2 pi FRL over R. So 2 pi F na to is 225. Ang L is 0.2 Henry. Divided by R, which is 10 ohms. So our Q factor will be 28.274. So this is our Q factor. And last is for the dynamic impedance. Solving for dynamics impedance, we have Z is equal L over CR. So formula base ra gihapon tanan. So our L is 0.2 divided by C, capacitance nga 2.5 negative 6. And our R is 10 ohm. Our dynamic impedance is 8,000 ohms. This is our final answer. So that would be all our topic for our final. So I hope nasabtan. And if you have any question, you can comment in our Google Classroom para matabangan ni ma'am. So that would be all. Thank you.